Have you ever imagined a spacecraft so far from home that sunlight takes over 20 hours to reach it? Voyager 1, launched way back in 1977, crossed into interstellar space in 2012, becoming the first human-made object to venture beyond our solar bubble. Its instruments, believe it or not, continue to relay whispers from the unknown, probing regions where cosmic rays and magnetic fields dance in this kind of eerie harmony. Here's the punchline. Voyager 1 is still alive, and it's over 14 billion miles away. Did you know its tiny plutonium power source will last until around 2025? Impossible encounter in deep space. A tiny spacecraft more than 14 billion miles from Earth suddenly shook the foundations of modern astrophysics when Voyager 1's instruments recorded an astonishing, milliseconds-long burst of high-energy particles unlike anything seen before in interstellar space. In that instant, every sensor on the probe lit up with an organized waveform, ruling out random cosmic noise and forcing engineers to confirm that this was no mere hardware glitch. At the same moment, Voyager's gyroscopes detected a subtle twist in its orientation, as if an unseen hand had tugged on the craft, and the usual 22-hour round-trip signal delay to Earth shrank by a fraction of a second, hinting at a fleeting distortion in the fabric of spacetime itself. No gamma-ray burst, supernova, or solar storm shows up in astronomical records for that region, leaving experts scrambling through three impossible theories: an extraterrestrial device projecting a focused energy field, a pocket of dark energy that warped electromagnetic propagation, or an interaction with a rare plasma filament weaving through the interstellar medium. Each hypothesis challenges the very core of physics textbooks, demanding we rethink how energy, gravity, and the unseen architecture of the void behave beyond the heliosphere. In the silent expanse beyond our sun's protective bubble, Voyager 1's incredible anomaly reminds us that even the emptiest reaches of space are alive with mysteries, waiting for humanity's farthest-flung explorer to uncover secrets that could rewrite our understanding of the universe. Glitch, just mystery. Voyager 1's ground team stared at the data readouts in sheer disbelief as every single diagnostic test came back pristine. No corrupted memory blocks, no voltage fluctuations, no code errors, nothing to explain the extraordinary energy burst. Systems older than most smartphones performed flawlessly under scrutiny, with checksum verifications confirming every line of onboard software was intact, and temperature sensors reporting nominal levels despite the ferocious particle spike. Even the legendary fault isolation protocol, designed to reroute power and reset malfunctioning modules in mid-flight, lay unused because there simply was nothing to reset. Engineers pored over thousands of telemetry frames, tracing each bit of data back through redundant pathways, and found no evidence of internal interference. If Voyager 1's ancient circuitry didn't generate the anomaly, then whatever happened out in the abyss must have been real, an authentic encounter etched into the probe's history. In that moment, confidence in Voyager's hardware soared alongside excitement for new possibilities, because ruling out a spacecraft glitch meant there was something truly alien at play in interstellar space, taunting our understanding and daring us to chase answers farther than ever before. Voyager 1's celestial Morse code. Voyager 1's data stream suddenly morphed from random static into what looked like a cosmic Morse code, a patterned pulse that left scientists both thrilled and baffled. In a fraction of a second, the probe's particle detectors and magnetometers synchronized to reveal a series of evenly spaced energy peaks, as though an unseen hand was tapping across the void. This wasn't the chaotic hiss of solar wind or the harsh roar of a gamma-ray burst. Each pulse repeated with hypnotic precision, spanning multiple frequencies and lighting up every instrument on board. Mission specialists pored over spectral analyses and discovered that the waveform bore hallmarks of an engineered signal: consistent amplitude, regular intervals, and a frequency sweep that traced a smooth arc rather than flickering unpredictably. Even more astonishing, the pulse sequence carried subtle variations, tiny shifts in timing and strength, that hinted at encoded information rather than a simple periodic disturbance. It was as if Voyager 1 had intercepted a secret broadcast, one crafted by forces beyond human technology. The phenomenon forced researchers to rethink assumptions about interstellar space being a purely random environment. It suggested that pockets of order could exist out there, whether born from exotic plasma structures, alien transmissions, or unknown quantum processes. Deciphering this patterned pulse has become a top priority, with teams applying advanced signal processing algorithms and machine learning models to tease out possible messages or physical explanations. As Voyager 1 continues its lonely voyage, every bite of this mysterious waveform could unlock groundbreaking insights into the hidden rhythms of the cosmos, and remind us that even in the deepest darkness, order sometimes whispers its presence in the language of light and energy. An unseen hand in the abyss. Voyager 1's gyroscope suddenly whispered of a cosmic nudge, an invisible twist that left controllers back on Earth scrambling for explanations. In the span of mere milliseconds, the probe's attitude sensors detected a subtle, inexplicable rotation, a change so slight it couldn't have been caused by solar pressure or micrometeorite impacts, yet unmistakable in the spacecraft's precise telemetry. Engineers pored over torque calculations, eliminating every conceivable onboard cause: fuel slosh, mechanical backlash, thermal flexing, until they were left staring at a phenomenon with no terrestrial analog. It was as though an unseen hand had reached across the void to give the billion-mile-old Voyager a gentle spin, bending the laws of momentum in a region we once believed too empty to exert any force. The unexpected rotation coincided exactly with the instrumented energy spike and patterned pulse, weaving a narrative of interconnected events that defy random chance. This phantom torque raises profound questions. Could Voyager have grazed a dark matter stream whose gravitational tides imparted enough leverage to twist the craft? Might it have skimmed the edge of an interstellar shockwave, where charged particles funnel a directional impetus? Or more tantalizingly, did it encounter an alien probe deploying micro-thrusters in a silent salute to humanity's farthest emissary? As research teams model this ghostly rotation, high-fidelity simulations and laboratory plasma experiments strive to replicate the torque under controlled conditions. Each test brings new clues and fresh mysteries to light. Voyager 1's unexpected pirouette reminds us that even in the supposedly tranquil expanse beyond the heliosphere, forces unseen and unfathomable still hold sway, challenging our understanding of motion, matter, and the mysterious ballet of the cosmos. Accelerated echo. Voyager 1's routine ping suddenly arrived back on Earth faster than light-starved engineers had ever seen, its 22-hour delay shaved by a mind-bending fraction of a second, hinting at a fleeting shortcut through the cosmic fabric. As mission controllers compared timestamps, they realized the signal's return lag dipped by nearly 0.02%, an anomaly far beyond measurement error, and repeated across multiple tracking sessions. This wasn't a glitch in ground station clocks, atomic time calibrations held steady, nor a misalignment in the deep space network antennas which showed perfect pointing accuracy. Instead, the only plausible culprit lay between the stars, a transient wrinkle in space-time itself. Some researchers propose Voyager skimmed the edge of a gravitational lens formed by a dark matter clump, bending its own radio waves and hastening their journey home. Others theorize the probe drifted through a localized warp bubble, an exotic distortion predicted by general relativity but never before observed, compressing the distance light traveled by mere thousands of kilometers. Intriguingly, this temporal quiver aligned with the same instant as the energy spike and phantom torque, weaving a tapestry of interlinked anomalies that defy conventional astrophysics. If confirmed, this phenomenon offers a rare glimpse into how gravity and quantum effects interlace across interstellar scales, potentially unlocking new methods for faster-than-light communication or propulsion. Engineers are now reanalyzing decades of archival data for similar micro-shortcuts, while theoreticians refine models of spacetime foam to account for Voyager's cosmic detour. In the silent expanse beyond Neptune's reach, Voyager 1's accelerated echo reminds us that even the void can surprise, revealing hidden pathways through the universe that beckon humanity to rethink the very nature of distance and time. The Cosmic Detective Story. Voyager 1's ground team frantically cross-referenced every astronomical database on Earth, searching for the cosmic culprit behind the impossible energy burst, only to discover that the universe had gone eerily quiet at the exact moment of the encounter. No gamma-ray bursts lighting up distant galaxies, no supernovae explosions sending shockwaves across light years, No solar storms from our own sun rippling through interstellar space. Absolutely nothing to explain what had just happened to humanity's most distant explorer. The Deep Space Network's massive radio dishes, which normally detect the faintest whispers of cosmic violence from billions of miles away, registered complete silence in Voyager's sector during those crucial milliseconds. Even more puzzling, the probe's location placed it in what astronomers call a cosmic desert, a region so devoid of stellar activity that it should have been the most predictable, boring stretch of interstellar space imaginable. Teams scoured records from the Hubble Space Telescope, the Chandra X-ray Observatory, and ground-based gamma-ray detectors, finding no trace of the high-energy phenomena that typically produce such dramatic particle spikes. The absence of any conventional explanation forced scientists to confront an uncomfortable truth. Whatever had interacted with Voyager 1 wasn't broadcasting its presence to the rest of the universe. It was as if the cosmos had conspired to create a perfect mystery, leaving behind only the faintest fingerprints on a single spacecraft drifting through the void. In the vast theater of space, where violent stellar deaths and explosive births paint the darkness with radiation, Voyager 1 had encountered something that preferred to remain hidden, making its discovery all the more extraordinary, and, honestly, a little terrifying. Alien architecture. When Voyager 1's detectors lit up with that impossible energy surge, engineers never suspected they might be witnessing the handiwork of an alien civilization experimenting in the dark. Suddenly, this 4-decade-old probe recorded a beam of finely tuned particles, not chaotic like a cosmic blast but precise, like a message or a probe's beacon interrupting interstellar space. Analysis revealed the burst carried hallmarks of intentional design, sharp rise and fall patterns, frequency shifts matching the characteristics of directed energy systems, and a coherence so perfect that natural plasma interactions could never replicate it. As the burst faded, Voyager's orientation sensors registered micro-adjustments in its attitude, as if tiny thrusters had nudged the spacecraft ever so slightly, another signature of a remote station device calibrating its aim. Experts theorize that Voyager may have passed through the scanning field of an extraterrestrial sentinel, its beams designed to map atomic structures across vast distances or to ping interstellar vessels for contact protocols. Alternatively, some propose that an alien research platform deployed a stealth drone using advanced metamaterials to cloak itself until it communicated with passing artifacts like Voyager. In either case, this encounter suggests that we're not the only technologists in our galactic neighborhood. Perhaps somewhere out there, hidden between the stars, lies an extraterrestrial network of sensors and beacons, silently cataloging the interstellar medium and cataloging every human-made emissary that dares to venture beyond its home system. Voyager 1's brush with alien technology isn't just science fiction come to life, it's the first breadcrumb on a trail that could lead us to the architects of the cosmos, challenging humanity to listen more closely to the silent symphony of space. Dark energy pocket. So, a sudden distortion in Voyager 1's data hints that the probe may have drifted into a pocket of dark energy, a region where the mysterious force accelerating the universe's expansion really takes center stage. In this hypothesis, Voyager 1 crossed into an extraordinarily empty patch of space, way emptier than the surrounding interstellar medium, where the repulsive effect of dark energy briefly overwhelmed all other influences. Instead of the usual cosmic rays and plasma interactions, the spacecraft detected these subtle shifts in its electromagnetic signals, frequencies that stretched and compressed as they moved through a volume governed more by space-time's expansion than by local matter. Within such a void, even light itself could experience a tiny pull outward, altering round-trip communication delays and bending radio waves in ways never observed inside the heliosphere. Now, laboratory tests and cosmological simulations suggest that dark energy-dominated voids can produce minute phase shifts and amplitude modulations in traversing signals, effects that would show up on Voyager's instruments as coherent anomalies rather than just random noise. If Voyager 1 truly sampled a sliver of this cosmic foam, its data offer us the first direct in-situ glimpse of dark energy's influence on electromagnetic propagation. Confirming this pocket would not only rewrite our understanding of the interstellar medium, but also provide an unprecedented laboratory for testing whether fundamental constants remain unchanged in regions where dark energy reigns supreme. As Voyager 1 sails deeper into the void, every distorted waveform and delayed ping may map out the hidden architecture of the universe. and reveal how the silent force of dark energy sculpts the fabric of space-time itself. Plasma filament interaction. Voyager 1's sensors just whispered of a hidden highway in the void, a dance with a ghostly plasma filament that left its instruments singing in synchrony. In the blink of an eye, the spacecraft crossed through a slender strand of interstellar plasma, an elongated ribbon of charged particles threaded by magnetic fields that acted like a cosmic waveguide. As Voyager tore through this filament, its detectors recorded a series of harmonized energy pulses and subtle magnetic fluctuations far more orderly than the usual cosmic roar. These narrowband emissions, first identified as a persistent hum in interstellar plasma, spanned multiple frequencies with consistent amplitude and spacing, signatures of a filament channeling and amplifying plasma oscillations rather than scattering them. Inside these filaments, density microstructures, ripples just a few thousand kilometers across, trace turbulent cascades in the interstellar medium, yet remain remarkably coherent over distances of billions of kilometers. As Voyager 1 pierced the filament, its plasma wave instrument saw sudden shifts in electron density and magnetic field strength that mirror laboratory studies of filamentary turbulence, where charged flows swirl around magnetic cores and generate organized oscillations. This encounter suggests that interstellar space is laced with invisible wires of plasma that can focus energy and guide electromagnetic waves, much like fiber optics over cosmic scales. Decoding the precise waveform patterns from this filamentary passage could reveal the filament's internal geometry, magnetic topology, and even the spectrum of turbulence within. By mapping these cosmic strands, Voyager 1 offers humanity its first in-situ glimpse of the interstellar web, a network of plasma filaments sculpting galaxies and guiding particles through the darkness between stars. Physics rewritten. Voyager 1 just dared the universe to redefine itself when its instruments logged a cascade of interlinked anomalies. Energy spikes, patterned pulses, phantom torque, accelerated echoes, silent sectors, alien-style beams, dark energy distortions, and plasma filaments, all in one astonishing episode. This isn't science fiction, it's a reality check for centuries-old physics. Traditional models treat interstellar space as a passive backdrop, a near-empty expanse where cosmic rays and magnetic fields drift predictably. Voyager 1's data totally shatters that illusion, revealing a dynamic, interactive medium capable of bending space-time, guiding energy with dazzling precision, and even hosting phenomena that mimic intelligent design. If an advanced civilization's technology fine-tuned particle beams across light years, our theories of field propagation and energy dissipation will need a radical overhaul. If dark energy pockets truly warp electromagnetic signals in situ, we must rethink the scale invariance of fundamental forces and revisit cosmological constants. Should plasma filaments act like interstellar fiber optics, then turbulence theories and magneto-hydrodynamic simulations require major revisions. And if localized space-time warps shorten signal delays, we might finally glimpse pathways toward faster-than-light communication or travel, once banished to theoretical footnotes. Each hypothesis emerging from Voyager 1's impossible encounter demands new equations, fresh laboratory experiments, and innovative space missions. As scientists race to integrate these anomalies into coherent frameworks, textbooks will change, graduate programs will pivot, and the next generation of space probes could carry quantum sensors explicitly designed to map these exotic phenomena. Voyager 1, the humble messenger from humanity's past, has become the herald of physics' future, urging us to broaden our understanding of reality and embrace a cosmos that refuses to remain static or simple. Thanks for joining Simply Science on this incredible journey with Voyager 1's impossible encounter. If you enjoyed unraveling deep space mysteries, smash that subscribe button and ring the bell so you never miss our next cosmic discovery. Drop a comment below with your wildest theory about what Voyager might uncover next, and let's keep the conversation going. Your support helps us explore the universe one breakthrough at a time. See you in the next video, Space Explorers.